Okay, today we're going to talk about area of triangles. We've already covered area of rectangles and squares. We've covered how to do perimeter of rectangles, squares, odd shaped figures. We've also covered how to do the area of parallelograms. So today we're going to talk about the area of triangles. Well, I have my I can statement there. If I can use the formula to find the area of a triangle, but then what did I draw? I drew a rectangle. But we have to draw a rectangle to understand how we got the idea, how mathematicians came up with the idea for area of a triangle. So I'm going to take that rectangle and I'm going to draw a line across the middle of it from one vertex to the other. Now, if I draw a line from one vertex to the other, you see that I have split that rectangle in half. Would you agree? Well, if I only look at this, moving my picture. If I only look at this part that I'm highlighting in green, what have you made? You've made a triangle. Well, to find the area of a rectangle, we were doing length times width. So let's say that the length of this rectangle was 5 and the width of this rectangle was 6. Okay, so how is that going to help me find the area of a triangle? Well, if you notice, we cut it in half. So my area for this triangle is going to be half of what it would have been for this rectangle. Well, what's the area of the rectangle? Look. On this side there would have been a 5 as well, a 6 up here, just like in the rectangle if there was a rectangle. But I only want the space in here. So I'm going to take my 6 from down here. Let me try that in a different color. My 6 from down here and my 5 from over here, and I'm going to multiply them. But if I multiply them, remember I'm going to get the space that's in here, all of this space, and I only want the part that's in green. So I'm going to multiply them, and then I'm going to divide by 2, which is the same thing as multiplying by a half. So I say length times width. Oh, that's 30. But remember that's the space for the whole rectangle. I want to take that 30 and divide it in half. Make my division problem over here because I have more room. Take my 30, divide it in half, meaning I'm going to get 2 parts. 2 goes into 3 one time. Subtract. 2 goes into 10 5 times. And my area for my rectangle, just this green area, just right here, is going to be 15 units squared. All right, so let's try it with another one. Go ahead and write your formula for a triangle's area down. Your area equals base times height divided by 2. Sometimes the formula for the area of a triangle looks like this. And the reason for that is that when we times by a half, it's the same exact thing as dividing by 2, because we want to times it, put it into groups of half of the item. So timesing by 1/2 is the same thing as dividing by 2. We just covered our multiplying and dividing fractions. So that's where that comes into place. So on our triangle here, it looks like we have a height of 10 and a base of 9. So we're going to go ahead and put, as my 8th grade math teacher would say, we're going to plug and chug. We're going to plug our numbers in. We have a base of 9. We have a height of 10. But based on the commutative property, I can go ahead and flip-flop those numbers however I would like to, because they're still going to give me the same thing. But we're going to do 9 times 10. Yep, all we had to do was move that decimal over. We moved it and made it 90. And then we have to divide it by 2. I don't have space over there, so I'm going to move over to this corner of my paper. 2 goes into 9 4 times. 4 times 2 is 9. Take away 8 is, and 2 goes into 10 5 times. So my area of this triangle is 45 inches squared. So what if we have a triangle like this where it's flipped on its side? Well, actually, I mean, you can't, it's not really flipped on its side, but you know. Usually there'll be some sort of dotted line, kind of like what we saw in the parallelograms, some sort of dotted line here that shows that right angle at some point. And they're going to have like a listing for this dotted line. The reason they do that, if there is not a right angle in as one of these angle choices, if it's not a right angle one of these places, you have to have this to show the height of the triangle, because the height is considered from the right angle to one of the other vertices. So in this case, none of these vertices were right angles, so it dropped it down to make the height of the triangle to be 6 inches. And over here we have a base of the triangle of 5 inches. Oh, that's kind of like the one we did at the beginning. So in this one we're just going to use that formula of a area of a triangle, base times height divided by 2, or 1/2 times base times height. And we're going to plug and chug. Well, 6 times 5 is, and our top of our fraction is bigger than our bottom, so it's going to fall into the house. 2 goes into 3 one time, and 2 goes into 10 5 times. So the area of this triangle is 15 inches squared. Let's try one more for some practice. Remember, our formula is base times height divided by 2. You should be writing this in your notebook. 9 4 2, plugging and chugging. 9 times 4 is, and the bottom is bigger than the top, so that top falls into the house. The 2's on the outside. 2 goes into 3 one time, drop down. 2 goes into 16 8 times. So our area of this triangle is 18 centimeters squared. Okay, so you need another clue for your secret number today. Your second clue for your secret number is that it is greater than half of 200. It is greater than half of 200. Head on over to Schoology, grab your assignment, and get to work. Happy mathing!